moving forward, does it still look like there's black marks up there?
It looks like a bruise. It's stuff goes over his ear.
Well, maybe someone went to me and went, "Whatcha!" like a ninja, just like that. I did.
I'll go back.
Okay. Yeah. Okay. That's not for entertainment purposes. It's for learning purposes. Okay. All right. Perhaps. No. Okay. So what we see here, if it's hard to read with where you're sitting or whether it's hard to read on video, upon trying to catch the roadrunner, okay, Wiley is a what? He's a coyote, okay? Always trying to come up with ideas to capture the roadrunner. What's significant about this is who's faster, a roadrunner or a coyote? A coyote is actually faster, I believe, okay? So that's the reason I say that is I think people say, you mean my childhood was not accurate, that coyotes are actually faster than roadrunners, which I think is perhaps accurate. So with that, we're just looking at this in this sense here, okay? So Wiley's trying to capture the roadrunner. So he's running east at 17.80 meters per second. What is a clone? I'm sorry, say that again. Like if I copied this AA battery, how many are left here?
None. Oh, what? 3. Sorry.
There's 3 in here. So these are all clones of one another. It means they're basically the same thing. That's what a clone is. So in this case, Wiley's got a clone of himself. They want to capture the roadrunner. So they're each moving in opposite directions. Okay? So Wiley's moving at 17.80 meters per second and his clone is running west. You might say that they're running in opposite directions. That's true. Well, opposite directions means they're coming towards one another. Okay? So his clone's running at 16.10 meters per second heading west. What does this stand for? Conservation of momentum. Okay? So in this process, Wiley's got a mass of 60 kilograms, and the clone has 74 kilograms. Then in part B, the reason this is so long is this is actually 2 problems in one. One of the things we continue to like to do is place some of these concepts that we've done before and place them into prior knowledge. So if Wiley began running over a time frame of 3.20 seconds, what was his force on impact? We're actually missing a variable here. Okay? So for those of you who really have a good understanding of what we're asking for here, just do one of these. Okay? So then for some who perhaps, I sometimes struggle with this, but we're giving it our best effort. Okay? What variable are we possibly missing? Yeah. You need to find the acceleration. But which we mean we're missing that. But what variable could we place on here? I think you said it.
Gravity.
No, not gravity, because we're not free falling. What do we need to solve for acceleration?
Velocity.
Which one?
Both.
Both. A final and an initial divided by time. So that wasn't intentional, just one of those aspects. Over the time frame of 3.20 seconds, we could say he began at, we'll say, 4.18 meters per second. So, sees now this is Wiley, it's not the clone. So don't get the two mixed together. So the best thing that you can do would possibly be what? So when we write down our information, how many different types of scenarios do we have going on? 1 or 2? Why is it 2? Which means you have to have 2 variables. One is Wiley himself, and the other must be what? His clone. Okay? So for Wiley, we've got the clone. Okay? Because of that. Oh, okay. Well, that's your choice then. All right. So, what do we know about Wiley? Okay.
His name is Wiley. He has a mass of 60 and a velocity of 17.8 grams. Oh. Layla.
Okay. So, what do we know about his clone then? So, what do we solve for those with this information then? What do we, okay, so what are we solving for? What are we solving for? I'm sure that's what we're discussing over here, right? First, are we doing that right now? Force? No? No, we're not. We're solving for what first? Let's go in order. For. No, we're not solving for velocity either. You do realize and understand we're trying to help you here, right? Would we agree with that? You would or wouldn't?
Literally just nodded my head, dude.
Oh, dude, try again. Can we proceed? Yeah, we'll maybe place the same effort that we're doing into this. Sometimes when we do that, the results don't pan out very well. Is that correct? Just I did see that. Okay. All right. We get out of this what we put into it. So what variable are these then? Right? What does the letter P stand for? It's a product meaning momentum. There's also a different letter P that we use, which is for what? Power. Then a third letter P that we could use for what? Pressure. So you remember we have more than one variable for this letter P here. So when we multiply them out, okay, we take 60 times 17.8, because that's what the formula would tell you to do. $1,068. Okay, then 74 times 16.10. Okay, once you get it to that point, are we done? No. What final step is there? You have to subtract the two because we're looking for a conservation, which means something is left over. So in this case, we've got 1191 0.40 and 1068.00. Okay. Okay, well, let's just borrow. We got 8, 3, 2. Okay. Does that look correct? 1, 2, 3, 4? That's kind of a coincidence that we did not plan that way. Okay. 1191.4 minus 1068. 123.40 kilograms per meter per second. Okay? Then, are we done with that yet? No. You're shaking your head no. Why are you correct? Because what we see happening, let's just use the directions that we have here. Okay? So if Wiley is running east, okay? Here's Wiley. And then if the clone is running west, okay? I didn't want to leave it just as W because you might think that's west instead of Wiley. Okay? So, who's got the greater momentum? The clone does. Okay? So then we've got 123.40 in Wiley's direction. Okay? Which means once they collide here, this much momentum is going to be moving in his direction. Okay? And then finally, we can solve for force then. Oh, the middle here? Well, we did on each side. Kilograms dash meter over second. Okay. All right. So then, let's see here. We get 255 newtons. Are we just saying that, or is that what we got? Okay, 255.60 newtons. Okay, in case you're wondering where that number came from, 17.8 minus 4.18 divided by 3.2 gives you 4.26 meters per second squared times 60 kilograms. That is Wiley's force. Oops, Wiley's force here. Okay? Front row, are we on the bus here? Second row. Oh, it was, I didn't know. I thought maybe there was a gang sign or something. Okay. Yes. Okay, is it for, I saw about 4 out there. Is it the conservation of momentum or is it the force? Acceleration. Okay, so if his final velocity is this, 17.80 minus the initial, which was 4.18. Do that first, divide by 3.20. That equals 4.26 meters per second squared. That acceleration gets taken times his mass, and that gives you the force of 255.6. That's where that comes from. All right.
The rest of the time is ours?
I don't know about that.
Where's the 4.26 from? Hannah, he just explained it. It's the acceleration.
Okay.
Mass, because he's
All right.